So this is my journey to TV ownership. So how do you own a TV? You find the brightest, cheapest 4K TV you can, and you go out and get it. Keyword cheapest and 4K. And how do you own a TV? Well, you need to define what own really means for you. For me, it means, you want to get a shell on the TV, not just any shell. We want a root shell. And when coming to this Lovecraftian horror, you don't want to set fire to the TV. So the key goal is not to break the TV throughout the process, because I'm going to get told off if I do that. Right, so how do we get to that point? Step one is find out what we're actually up against. So look at the marketing material for buying the TV, support material for people working on it, and has anyone hacked the TV before? What can we find that, because really you want the easiest path, and if the easiest path is someone's already done this before, no point reinventing the wheel. So marketing material, I typed in the TV model into the Philips website, we got 5 hits. The top hit has the exact keyword in bold, and when you click it, it redirects you to the homepage, because that page no longer exists. So when it comes to New Zealand Philips, you can't find the exact model anywhere. And if you go to a general search, they look like they didn't make any TVs from 2017 to 2019. They have TVs older than that and newer than that, but they just lie about not producing anything in that window for some reason. This is a 2018 model. So more searching on that. Philips is coming to the Indian TV market, or if the 6700 series. If that looks familiar, that's what I searched, because that's the range I'm in. And that web page says it is running the Linux-based Safi engine. So most smart TVs are probably running Android these days. But as I said, I went for the cheapest option. So you don't get Android. If we run our own Philips Safi engine, then we can cut the processing power down, because we don't need to run the full stack of Android. Looking further for Safi, I came to TP Vision. So TP Vision is the licensee for development and everything of Philips branded TVs. So if you buy a Philips TV for the branding, they didn't make it, TP Vision did. The Dutch company also. But yeah, so it's not my Philips TV anymore, it's the TP Vision TV running Philips Safi. Support material, so went through the user manual and the operating manual, which takes you through to the compare guide, which you get to hear about in the service manual. Key things out of that, well, I got an open source declaration, so I know what Linux libraries are running on the box. Got a few secret codes. If you know the IMSI code generator on your phone, turns out your TV has a few of those as well. Mainly for user service alignment, to get the edges of your screen right and things like that. And most importantly, if you forget your PIN code, so adult parental lock on the TV to stop people changing channels, you can use 8888 to reset that. So if you read the manual, you get some secrets codes out of that. This is the Philips Compare. As you can see, it's got a whole heap of ports, mainly for diagnosing TV issues. And down the bottom there is the cable and the pinout for my given model. So what do we know already? Someone's hooked up a USB UART to the TV, so instead of the Compare, we can hook directly to the TV. There's the naming guide, so for a given TV model, if you speak German, you are now able to work out what settings of the TV, is it an LCD, is it an LED, that type of thing. Single tuner, dual tuner. Google Translate helps for that as well, obviously. Equally, I found a Portuguese site for downloading all the manuals, so you seem to be manual downloading site was Portuguese. And if you speak Maldivian, there's a .ml or .mk domain, which tells you how to map model numbers to chassis, so they get one TV chassis and they load a whole heap of different LCD or LED type things in that chassis. So if you want a mapping of the physical casing of the TV to your model number, then you can speak Maldivian and find that, or Google Translate it once again. And quite interesting, OpenLG TV project. They support extracting firmware for various models and brands, which implies that there might be some IP reuse between these different TVs, so any research you find might be cross-applicable. So what do we have in existing research? On a Hisense TV, someone found you can go to Hisense Debug and install additional apps in the TV that way, side-loading them, and the HTML5 apps, and running the file URI and the file APIs, they could get straight in and access read-write access on their TV. Unfortunately, Hisense Debug doesn't work on a Philips TV because it's not a Hisense TV. This was my personal favourite. Someone found on their hotel TV, which is a slightly different architecture for TVs because they've got centralised management, that if you set the TV name to backtick sleep 5 backtick, it takes 5 seconds to save that change. So, direct command injection there, I'd imagine the back end on that is they're using a shell script to write it into the Etsy hostname or something, and if you just directly dump that in, you're going to get direct command injection. Again, didn't work on my TV for obvious reasons. This is a Sony Vizio vulnerability where they didn't have signed updates by the look of the payload, so they just installed a malicious update and they had shell on the TV that way. Getting slightly better to topic, this is a Philips vulnerability from 2013. A joint space API, which is used for sending keyboard remote control actions to the TV. You'll find that ////proc CPU info tells you a little bit about MIPS. So there's a command injection in there. Unfortunately, if in the 5 years of making my TV, they'd patched that, but that service was still available. And in 2014, Philips had a libupnp vulnerability of a buffer overflow. Had a quick look at the payloads for that, and then promptly went, there must be an easy way than binary exploitation. If I hadn't skimmed out, you go to the Android debugging menu, and on your Android TV, which costs a little bit more, turn ADB on, and then you can directly shell to your TV that way, or you can install Telnet and get a shell that way. So yeah, if you don't cheap out on your TV, there's a lot more options to getting root on it. So, after failing all the existing research, I went for some new research. So this is the bottom of the TV, someone else's model of my TV, because I don't need to take a photo. And what we've got on there is HDMI port, which you can actually send commands over. HDMI is or especially ARC is a bidirectional, but standard HDMI, you can still push commands to the TV, so we've got a potential ingress there. The TV antenna, now we've got digital TV, you've got MPEG-4 encoding type things. If there's a bug in the encoder, you could potentially compromise the TV using the aerial. Again, that's not the easiest path, I'm assuming. Networking, it runs various services, so some of those services are potentially exploitable, like the joint space. So you can port scan that and look at that. There's got USB port there for obvious flash drive file system stuff. But also, if you plug in on-the-go type devices, we might have a vector there to look at. And if you look at the official documentation on the left there, they kind of neglected that little ServU port you can see in the component video there. So they don't really tell you about that, but we saw the compare device which plugs in there, so that's a pretty good start. And we got the TV remote actually putting in those codes we discovered and running through the smart TV features. So web browser attacks, we could exfiltrate the user agent there. This is on a About debug or Chrome About or one of those built-in things. Also note there that copyright isn't copyright Philips. And it's not copyright Chrome, it's not copyright Opera, which is the base of the thing, and it's not copyright TP Vision. That's viewed software. So hitting this endpoint, I was like, okay, who the hell is viewed? They make TV operating systems and TV browsers, and yeah, it turns out they also have a TV emulator, and looking at the output of all of that, it looked very, very, very similar to my TV UI. So my Philips TV running Philips Safi is a TP Vision TV running viewed. So once you get that information, you open up a few more searchable endpoints to see what people have been up to. So having that documentation on the serve viewport, that was handy. So we know the pin out there. So I just need to go out and buy a JST PHR3 2mm pitch adapter, or grab a ribbon cable with a broken monitor power supply I had lying around it, some heat shrink. So that's my actual TV there, with my makeshift serial connections in there. Heat shrink's important because you don't want to short out the cables. So moving on to the manual, it supports FAT and NTFS as anything doing user stuff, and a heap of file formats. Tried malicious file names, so did some pipes and quotes in there. Did see that pipes broke the preview, so instead of showing the picture of a pipe in the file name, it just had a black spot there. I thought there might be something interesting there, but didn't really find any progress on it. Tried some FFmpeg and ImageMagick CVEs because who patches? No luck there either. But then the key one there is it supports FAT, NTFS, and what if I put ext4 on there, because what self-respecting Linux CV wouldn't run ext4? So this is from the ServView serial output. Doesn't seem to have a valid NTFS, but it mounted it anyway. So the good news with ext4 and a Linux CV is that you can put symlinks on there. So here is my new data tracking exfiltration point. I have a symlink called Rooty Boy, which points to the root of the TV's file system. So now I can view folders and any media on the thing, because the media browser only shows videos, pictures, and folders. But that's the etc directory of the TV, just by putting a symlink on a flash drive. And there's the Wi-Fi adapter that it's using in RT2870. So I had a quick look if there's any CVEs for that, but again, that's not the easiest thing doing with starting to hit symlinks on a flash drive. So now I want to get a read and write access to the TV. So I did every possible egress I could find on the TV, went through and did backup channel map, backup data, backup display lineouts. So this is the flash drive where I exported everything. Third_readwrite.txt was kind of handy, tells you all the large files, so if anything's getting too big they can diagnose that. Heap of bin files, going back to the don't want to see the TV on fire. If you modify a bin file and re-upload it, there is absolutely no knowing what that's going to do. They're labelled, but what does that given bit do in a binary file? No idea. So the two that I found was syslogo.tar and user, which both user being a directory, seemed kind of handy. So when I made those files, this is the log on the serve viewport. So you can see tar, unfortunately a -c at the end there, which is a sandboxing to a directory type thing, and a general copy files from here to here. So from that I tried to copy a file into the system there, and so it's really to get an arbitrary place on the file system now. It's a bit of a game of symlinks and putting files on there, symlinking back on your thing, and then so we've got the fox, goat and cabbage puzzle, if people know that. Trying to get things copy to flash drive, copy back to flash drive, and you get to choose what goes at each time. Plus the Aperture Science portal gun. So I copied my payload up to the TV. I then put a symlink back on the flash drive. So now I've got my file in the TV's user directory, the pictures user directory. Put a symlink on the flash drive to where I wanted it to go. And then, so this is where I found out where to go. I used the OpenLG thing to decompile the firmware for the TV. Went through auto-starting files. And found this one, which is pretty good. It's any directory in basic third ini. We'll have a file in it called global m setup. And then we're going to run that file if it's there. So that means I can do that by copying a folder, which is a lot easier if that symlink process, containing the payload rather than copying just a file. So I did that, and read-only file system. So trying to copy that shellsploit.ping over there. My symlink was pointing to basic./third-ini, and that is read-only. So I cannot copy files into there, so I need to find somewhere else to copy files. So then I played the Rabbit Hole, which is a game where you look at RC Local to see what starts on boot, then see that calls out to basic auto run, then you run out to basic auto run, and it will load a file from third read write browsing engine global M setup. Now the catch of this is it's a standalone file, so the symlinking process for the user path isn't going to work too easily, but too much thinking there for me. But this comment for debuggable issues, that makes me think the file doesn't exist, and if it does exist, it won't break the TV. So this is a perfect file for this thing. So then I worked with the tar thing there. There's a couple of early 2000 tar vulnerabilities to try. One, you can directory traversal, .. in the file name, and it will break out. But because they had the -c sandbox there, it means you can't get out of that hierarchy. Another one was a symlink in there, so you can untar a symlink and then untar a file over that symlink. But they've mitigated that as well by doing symlinks last. But yeah, if you do the untarring twice, the first one unpacks the symlink, and then the second one unpacks a file through the symlink. So that mitigation only works if you untar a file once. If you untar it twice, you can get around that. Yes, so I dumped a whole heap of cliche hacker images on the TV for the sole purpose that going through my media browser, I can actually test if the file got up there or not by navigating through the root symlink and seeing if I got to actually write the file I wanted. So then I also loaded BusyBox on the TV because we want an extra few tools on there. And uploaded into that global in the read-write directory because you can write to read-write a BusyBox netcat bind shell. Ta-da! So now I've got the host name, which is the MT5886, which is the MediaTek chipset it's using BusyBox for who am I, because it doesn't have who am I built in. And I'm at root already, because embedded systems, everything runs as root. So that's your root shell straight up, no previous required. And ls, there's the file system showing we got a few file accesses. So what do we want to do? Post-exploitation, well, I've got a netcat blind shell, but that doesn't send through Control-C or anything, and it's a bit annoying if you start a command and can't stop it. So getting drop beer, which is a popular SSH client and server for Linux and embedded systems primarily. But the issue is there isn't an Etsy shadow, so there is no root password, so I can't log into it because you need authentication for the drop beer. So how do I set that up? Well, I got the source code and cross-compiled it, adding one line of code around the if password equals password. I just added an or true. So I've compiled dropped beer, which is a drop beer client which accepts any password you give it. So now I've got an interactive shell on the TV, and I can Control-C out of it. It's a full SSH instance. So naturally, I put Debian on a flash drive and root it into it. So now I've got a package manager on my TV, installed the Nmat from there, and now I've port scanned my house from my TV. DD the memory card or the memory block of, so that's the entire file system, the entire disk of the TV. Outputted that to a flash drive, so now I've got a full disk image of the TV. And the final point is mount bind. This is the very important one. So this is a command that temporarily clobbers files and folders. So you can replace, like if you didn't like the loading screen, you could replace the loading screen and all the animations. It's all HTML5 interface, so you can change what you want there. And the key point about mount bind is, if you mess something up, TV stops working, you reboot the TV, and all your mount binds disappear, and your TV is no longer on fire. So that's why you don't just blindly clobber files. If you mount over them, you can save the TV from that. So what next? Well, Sony also used Viewed, so that kind of explains why OpenLG TV had a lot of supported things, and Sony no longer supports Viewed. So if in the future Philips decides to drop support for my TV store, I can't install any more apps, at least I've got access to the TV and I can do what I want to it. So locked out there. And that joint space API, which was present and enabled by default on my TV, they went through a window where they didn't have it, then they had it by default, and then you had to enter a code on your TV to enable it. So mine's in the window where it's enabled by default. And if you think why they have the code to enable it, it's because it's not exactly secure. So you can CSRF the joint space API, so you can send someone to a website on their phone, and then their TV just turns off. So yeah, if you want to disable joint space on TVs, or if that's enabled by default, this is a Philips specific thing. You can use your shell access on the TV and chuck up some firewalls on the TV, or you can block it with network firewalling, but the TV can block it itself. And I think I'm a little bit over time, so thank you for going over time with me.